Hi, thank you, welcome. First of all, I want to apologize that I'm not wearing a onesie. I had one on, I took a nap, then it was time for lunch, I was just running out, and then I broke everything, so. So let's start. It's the last talk. You probably all want to go home and dress up for the party. So what I want to talk to you about is named Alpha 2048, and that is basically the name that I gave a prototype that I wrote to learn a specific game. Like, I'm doing a lot of machine learning, and I just wanted to do something that's fun, because data science is usually very boring. So that's me. I'm Lian Li. This is not me. This is a case by a company named Lian Li. It says here that, no? So if you ever see something like this, this is not me. So if you want to follow me on the interwebs, my nick is Chimney42. So you can follow me there, GitHub, Twitter. I'm also on Mastodon right now. I don't know if any of you, yeah, right. So, but I didn't find a logo that I could use, so you have to just look me up there. All right, so like I said, I'm a software engineer mainly, so I'm doing normal software development stuff. I'm also a self-proclaimed data scientist, because no one in my company does data science except for me, so just well, that's me then. My company is named Datenfreunde, and we're mostly doing data journalism. So we're doing a lot of agency stuff for ARD, Tagesschau, stuff like that. And also we have our own product that's it's called contextualized news servers. So basically the idea is that you get the news that you need, not the one that you deserve. But in my spare time, I call myself machine learning enthusiast. I don't have the academic background, so I didn't study math or IT, and computer science, I think it's called. Mainly my background is doing online courses by Ang. I don't know if you know Andrew Ng, very great guy, and he created this learning platform Coursera, and they have a lot of cool machine learning courses if you want to look into that. So that was just a short introduction about myself. Let's go on to the game, because we don't have that much time now. So the game, the first iteration of the game was called Threes. And I don't know, maybe you've seen it, maybe you've played it. Basically, the idea is that you have tiles with values on them that are either 1, 2, or multiples of 3. And you have to merge either 1 and 2, or 2 tiles of the same value. And then they add up, and you get a multiple of 3, and you play it until your board gets full. So that's the game. And after Threes came out, it's like what it is in our industry, unfortunately sometimes, is that a lot of clones exploded. There were a lot of clones. Most of them are slightly different, because they're not based on multiples of 3, they're based on multiples of 2. There, as you can see, there's a lot of different games, a lot of different versions. My favorite one is this. I know, right? I get this is a bit harder, because you don't know if I merge those two, which one do I get, the pizza dog or But I guess it's fun, so try it. But the implementation that I'm going to focus on is this one. It's open source 2048. Main reasons why I picked this one is it's open source, and it's completely in JavaScript, so it runs completely in the browser. That's nice, because you can look at something, and it's pretty. Okay, let's go over the rules one time so we are all on the same page. So first of all, the game is played on a 4x4 grid. As you have seen, it's 4 tiles by 4 tiles. Then each turn, you take an action, which I named alpha here, and alpha is one of those 4 integers. So it can be, they're mapped to the directions you can swipe to. So 0 is up, 1 is down, I think, and 2 and 3 are left and right. When you do this action, and you can merge 2 tiles with the same value, with the value v, then the result will be 1 tile with the value 2 times v. So those tiles get added up. And after each action, so no matter whether you merge something or you didn't merge something, a new tile is added to an empty space. So over time, your board will get fuller and fuller unless you can merge every move, but that's usually not the case. And there's also a probability distribution. There's a 90% probability that the new tile value will be 2, and there's a 10% probability that the new tile value will be 4. And as I said before, it's multiples of 2, so the smallest possible number is 2. Right, and so you can lose this game when no more moves are possible, when your board is completely full and you can make no move in any direction. Sometimes you can make a move in one direction, but you make it in the other direction, then the game will just ignore that. It will just force you to do the right move after some time. You can win once you have one tile with the value of 2048 present. So when you get that, you win, but you can still keep on playing. I've never reached it. That's why I built something to play that for me. And then also this particular implementation has a score. And the score is it's a numerical value. And every time you merge 2 tiles, the sum of those tiles is added to the score. So the score increases every time you merge something. So this is the game, and I want to talk to you, like I said, about the prototype. So who gets the pun? There's just one guy who held up his hand and just immediately went down again. So yeah, it's who wants to say it? Yeah, exactly. So it's there are some things AlphaGo uses that is I also use that, but not as sophisticated as Google does it. But I was yeah, it's close enough. So I had a few constraints for this prototype, and I want to go through them real quickly. So the first one was JavaScript. Main reason for that is I love JavaScript. Who doesn't? It runs in the browser, so it's you can just have everything in your browser. You don't have to have a server or anything. So yeah, and also I just like giving machine learning talks at JavaScript conferences. It's a really cool thing to do. The second constraint was that it needs to be supervised learning. And the main difference between supervised learning and unsupervised learning is the way that you can train your system is different. So if you have supervised learning, you usually have labeled data. So you have a description of a situation and then a label for it. For example, you have a description of a person and then the label is, let's say, female. And then you have a description of a person, and the label is male. And then you train a system to predict whether this person is female, male, or one of the other 10,000 gender options that there are. With unsupervised learning, usually the goal is to find a pattern, so that you don't know the pattern yet, but you want the system to find out if there is a pattern, and if there is one, it should cluster the data so that you can name it, so that you can give it a label. That's the main difference. So some of you already know that I've already given a machine learning talk a year ago, and I predicted soccer scores, and I used a library named Synaptic. Synaptic is a neural network library for JavaScript, and so I used it for classification. Classification is basically just categorizing things. There are other things that you can also do, like regression, where you approximate a value, a numerical value, but just look for yourself. The blue thing means that it's a link, and I'm gonna upload the slides so you can just check it yourself. So yeah, like I said, I already have prior experience, and if you want to, there's a link to the GitHub project where I predicted soccer scores, and it worked well enough, I'd say. Was well enough for a talk. So I decided, okay, I'm going to do JavaScript. I'm going to use Synaptic because I know it already. It's JavaScript. It's perfect. How do I go about doing that? So the first step is to gather data, and because you need the data to actually train your system. If you don't have data, you don't have nothing to train for. So the way that I thought would be like a good idea was to just simulate all possible actions. So basically the idea is you have a state that your board is in, and you have 4 possible actions. And then you will simulate each action. So I simulate a swipe to the right, then I reset the board state, and then I simulate a swipe down, reset the board state again. And each time I simulate the board state with a specific action, I will check after that whether the score increased. So by that I know I moved to the right, did I merge something? Because the score only increases when I merge something. And then, after I've simulated all those moves, I will reset the board state again to the state it was before I simulated the moves. And then I will just pick one random move to do and to progress the game. The reason why I'm doing a random move and not like looking for the action that is like the one that will increase my score is I wanted to have a random baseline. I wanted something to compare. And if I had just chosen picking the move that will give me an increase in score, then it's kind of boring because I don't really know how if it's better than just randomly playing the game. And the way that it would look is to have inputs and outputs. So the input would be the board state. It's a serialized state where each tile where there's no tile in it has a 0, and if there is a tile on the cell, it has the value of the tile. And this is from top left to bottom right. And then the actions are basically mapping whether the score increased for each action. So in this case, action 0 and 1, so with the index 0 and 1, they didn't increase the score, but action 1 and 3 did. So this is the training data. And then I had to train the network, and I'm not going to bore you with the details, but basically you just like shove all this data in and then just let it run for like 2 days, and then you just use it to make predictions. Pretty easy. So okay, had to train the neural network. Like I said, if you want to check out how to do it with Synaptic, you can just Google Lian Li, machine learning with Node.js, and some video will come up, hopefully. It will explain it. Oh no. So I'm training my neural network, and then I predict whether the score increases. So I trained the network to find out for each action whether the score can increase, and this is the prediction that I'm going to make. And then the result you get is an array with values in between 0 and 1. Those are probabilities. And then I will make the move where the probability that the score will increase is the highest. Pretty straightforward. And like I said, it's pretty boring, but the conclusion basically was, for me, that it didn't work great, which is not that surprising. So the problems that I figured was that, so first of all, it emulates a given strategy. So it's not really learning by itself. It doesn't make any creative decisions. It's basically just learning from the moves that you showed him. That's all he knows. So that's not very helpful if you're just doing random moves. Also, it just needs more foresight because it only checks whether the move will increase the score in the next state. But what if there's like a sequence of moves where I don't increase the score for like 2 moves, but in the 3rd move I will increase the score by, I don't know, 10-fold or something. That would be something interesting that I would want my system to learn. But the way I set up the whole Synaptic prototype didn't work out so well. So what I was doing after that, just going like into my thinking room, which is Google. And so I then tried to find like a better way to do what I want to do, and it's called reinforcement learning. Reinforcement learning is a really nice way to basically continuously teach your system things. And reinforcement is just like you reinforce like good and bad behavior. That's exactly what we're doing with reinforcement. It's exactly the same thing. And because it's like hard science, I did a lot of like mathy sounding slides. So I have a state that is this vector, and I will map on the state. I will map on the state the 4 possible moves, and then I will get a reward. So for each of these, so for one state, each of these 4 possible actions will give me a different reward. I'm going to show you what that means later. 2 things about reinforcement learning. Basically, it has like 2 great things that we'll need later. The first thing is called delayed reward. Basically, it means that I don't have to like do an action and then immediately reward my system. I can do like a lot of actions and then reward my system in the end, which is nice because then it can learn that there's a sequence, there's an episode of actions to be taken, and then there's a result at the end, which is exactly what we wanted for the foresight thing. The other thing to consider is called exploration versus exploitation. And the idea is that exploration means that the system will try out different things that it hasn't tried before or that didn't work out as well as before, to gather more and new data, to gather a big variety of data. And the opposite is called exploitation, which just basically means it will only do the move that it knows it's gonna give him a high reward. So you kind of have to balance those 2, because if you're a kid, it's nice to learn new stuff and do all kinds of things, and when you get older, maybe you just focus on the things you know you like and you don't try as many things that you already know you don't like or that you never heard of, or there's a saying in German that the farmer doesn't eat what he doesn't know, something like that. So that's basically exploitation. There's another concept. So it's basically an algorithm within the reinforcement learning idea, which is called temporal difference learning. I'm going through this real quick because it's not that important, but I want to have told you that. So temporal difference learning, basically, it's exactly what I said before. So that we know that there are several actions that are sequences that can lead to a specific state. So it's not only one action leads to one state, but there are a sequence of actions that will lead to a state. And I'm going to skip those 2 because it's, like I said, not that important. Oh yeah, so we're getting to the nice thing about JavaScript is that there are frameworks for everything, frameworks and libraries for everything, basically. And of course, there's also a library for reinforcement learning in the browser. You can thank Andrew Karpathy for that, who is now the director of AI at Tesla. And he used to he wrote a paper on the DeepMind people were using reinforcement learning to teach a system to play Atari games, and then Karpathy was like, oh, let's do it in JavaScript because I don't know, because I wanted to have things in the browser, I guess. So reinforceJS, you can check it out. It's fairly academical in the documentation, but when you get to the end, you'll see that basically all you have to create is 4 lines of code, more or less. I hid some stuff here. So, but what you need to basically do is have a state which is an array of integers again. Like I said, it's the same thing. It's a serialized board state. And then you get this agent from the library, and you tell the agent to act on the state. So you give it the state and say, act on it and give me the action that you think I should take. This is an integer 0, 1, 2, or 3. And then I will calculate the reward for the action. And what I'm doing here is basically playing the game. I take the action, and in this case, I'm simulating the key press, and I'm looking at the board, and then I will calculate some kind of reward from the board state or the score or whatever I can think of. And this reward I will pass to the agent and tell it to learn from this reward. In this example, I'm not doing delayed rewards because I'm acting and then immediately rewarding, but I can also just call act a number of times and then rewarding in the end. So basically, when we use something like reinforceJS, our whole problem, our whole engineering effort becomes just this one function, basically. So in this case, the reward, which is the important thing, which is the reinforcement that you want to do, is the result of the function Q from S, the state, and alpha, the action. So all we have to think of is a cool value that we can give our agent to tell it that was good or that was bad what you did. So I like to work in iterations because it's like easier for me to not remember things. And so in the first iteration, of course, I'm using like the simplest thing I can think of because I'm like super lazy and everything. And the simplest thing that I could think of was just like use the score as a reward. So the score is like, it already has been calculated. The one thing about the score is that it's always positive. It never dips into the negative, which can have like implications. But yeah, I was just saying, just use it to have something to start with. And I want to show you this graph basically. So I let it play like a bunch of games. And those are, the green lines are the absolute scores at the end of the game. So at the end of the game, I check the score, and I just wanted to see, like, if there is a learning, we should see like a curve going up, or like the peak going up. The yellow line is the average. Let's take a look at that. So this is the average, and as you can see, it doesn't look like there's like learning in any way. So that's kind of disappointing. But anyway, that's why it's the first iteration, because it's like the first is always, not so cool, and then the third is the one to go. So in the second iteration, I tried something that was also in the documentation. So it's like, if it's in documentation, it can't be that wrong. It's called decaying epsilon over time. And epsilon is the exploration value. So I talked about it before. Exploration is like doing a bunch of stuff, new stuff that you thought wouldn't be like work out as well. And you can like set this value to whatever you want, but it's a good idea to have it like become smaller over time. Like I said, like as a kid, when you start out, you want to like try everything, and then over time you're like, okay, I know now that this is the best move in this situation, so I'm just gonna do that. So the way that I did it was basically every 100,000th game or so, I would just decrease the exploration value by half between what the value is and the minimum that I set. And the minimum was like 0.02 or something. And the highest value from which I started was 0.7, I think. So those values aren't big or anything. Yeah, but like I said, the documentation said to do it, so I did it. And this is what I got. So yeah, the green lines don't really tell anything. The interesting thing is the yellow line. And this looks much better now. I don't really know what happened here. So this is like, wow, that's great. And then I think, oh, it's 4 a.m. I think that was when my laptop died. Because it runs in the browser, it takes a lot of space. But still, it's a good tendency. Like you can, I'm gonna keep that. I'm gonna keep that because it looks like it did its job. I don't know. It could be anything happen here. It could be just like a bad string of games. Okay, so now let's go to the third iteration, which is always like the best one, of course. And in the third iteration, I don't have that slide. In the third iteration, I basically I added everything. So I had the epsilon decay from before, and then what I did in the third iteration was delayed reward. I was rewarding after every action before, and now I'm only rewarding after the entire game is over. What do you think? It's gonna be cool. So yeah, again, not much to see, but look at this, look at this. Okay, I also have to say, I kind of cut out the prettiest part. It's not so there's like a slight dip here, but it's not, I promise, it's not like the one we've seen before. So I'd say that this is a tendency that I would be not ashamed to tell people that there is a learning. So after I did a lot more iterations, but I'm only showing you these 3 because it's that's basically the things that are the learnings that I had was that those things mattered the most. I tried a lot of different rewards, like I tried to calculate a rating dependent on the number of tiles that are present on the board, and what's also a good idea is like just take like the number of empty spaces that can also work. So there's a lot of like different things we can try. Whatever you think is worth the hassle, basically. So, but in conclusion, I think so that seems to be some kind of learning, but I don't know if you've seen it before. It's like it's always more or less the same the same value where the score will not pass like around 1.2 maybe, yeah. So I was thinking maybe there is like a cap. Maybe there's a cap on the board size because every time tiles are added and at some point the board is just full and you can't add more tiles and it's not like it doesn't grow bigger. So there's a natural cap on the game. Also, another problem was that the layers, so it's a neural network, but there's only one hard-coded layer in it. I hard-coded a second layer. I tried to like do it dynamically and everything, but it was a really big hassle. I emailed Kaparti, but he's kind of busy right now. But maybe he like take a look at my pull request someday. So I added a second layer to combat the flat input problem because we have like a one-dimensional array, but the board is two-dimensional. So there's like an implication that there are implications in the column that the system might just not get because it's just one-dimensional. So I was thinking maybe if I add a second layer, that would be something that the system will learn like implicitly, but I can't be sure because it's really hard to reverse engineer machine learning. I'm missing a lot of slides. What happened? If you want to check out some of like reinforceJS, I would recommend you to take a look at reinforcement learning itself first. It's like what is the mathematical reasoning behind it? Because it gets, like I said, it gets really academic and you have to Google a lot. Okay, so I said live demo. Let's see if I can make that happen. It's really not that interesting, I have to say. But, Okay, so I don't have a pre-trained thingy because I had like a course problem with my CouchDB. I know it's very embarrassing. But yeah, so this is how it looks like. It just runs, and I set up like the Grafana next to it. Oh, sorry. I can't find my mouse. Thank you. So I said it before, the hardest part of working with this is not getting distracted by the game. So I started the simulation at night before I went to bed, and then I was just sitting there for half an hour and just looking at it. It's just like, move to the right, yes, move to the right, nice. So I encourage you to try it out for yourself and just play around with it a little bit. Like I said, everything runs in the browser, so you don't have to like set up anything really. And yeah, that's basically it. Like I said, I'm going to put up the slides, and I'm going to put up the correct slides then. Thank you.